A reminder, part twos. Part twos are all 2 points apiece. I consider them multiple choices without the multiple choice. They should go pretty darn quick. If I say should, because they should go quick if you know your facts. Watch how quick this one goes if we know what the heck's going on. First thing, I have 4 arcs up here on this circle that are in a ratio of 2 to 3 to 5 to 5. Let's go. At this point, what are we doing with numbers in a ratio? Put in X's with them, unless it's a partition question. All right, this one's not. So yes, I'm putting X's with them so I can make an equation and I can solve for X. So on CD, I'm throwing a 2X. AD, I'm throwing a 3X, and the other 2 arcs are 5X apiece. I put the X's with them so I could set up an equation to solve for X. All right, where's that equation going to come from? What do you know about all 4 arcs? There's no missing ones. They add up to 360, right? They add up to 360. So I add up all the arcs. It gives me 15X, and I set it equal to 360. Solve for X, substitute it back in. Go ahead. You get all the arcs now. 48, 72, and 2 120s. Now comes the actual question. Do we know our facts or not? Find angle B. Find angle B. Friday, for people who weren't here Friday, we talked about how to find an angle that's located on the outside of the circle. Take a look at that video. Now we're looking for this angle, angle B. First, what type of angle is that? That's called inscribed angle. Yes, that angle B is inscribed. How do you find it? What's the rule to find any inscribed angle? That is taking half of an arc that it's drawn to. And this is why I suggest colored pencils or highlighters to say, I'm going to highlight angle B, and now it becomes very obvious the arc that it's drawn to. Not just one arc, multiple arcs. So I'm going to take half of arc A, D, C. That's the one that angle B is drawn to. So I'm going to add 72 and 48. We're going to take a half of a $1.20. And there you go, angle B, 60 degrees. It's only 2 points. That was pretty easy. I know it was, but it's only easy if I know my inscribed angle facts. Right? Next thing, I want you to make sure you're good with everything. I'm going to throw this at you now. New question. Do you remember the circle fact about an inscribed quadrilateral? What do I know about angles D and B? And the same thing is true for A and C. I want you to go in knowing everything you can here. Doyle, you think you remember? Darn right they are. Good job. They're supplementary. Okay, so B plus D equals 180, A plus C, and that's only for an inscribed quadrilateral in a circle. Going over everything I can. I don't want you to be good geometry students. I want you to be machines when you walk into Gym B on Friday. Okay, machines, savages. All good. All right, it's about time we review this now. Number 33. Take a look. Part 3 question now. So I think it's 4 points. It's going to show up, right? We know statements, reasons are going to show up. I don't know which part it's going to show up here. This year it showed up in part 3. Could show up in part 4 next Friday. And on top of that, I don't have any advanced knowledge. So maybe it's a congruent triangle proof. Maybe it's similar triangles. Maybe it's quadrilaterals. I don't know what it's going to be. All right, I don't know what it's going to be. So we got to be prepared for everything. So we might as well start with this one, which is not that bad. Just giving some of, not that we're lazy in here, right? We're not lazy in an honors class. Teachers are told to take a point off if you do not write the givens in. Or if you draw an arrow from the givens to the statements, we are told to take a point off. Okay?
We should even parallelogram PQRS.
Yeah, everything. Yep. Now, I don't care what you do right now. That's your deal, what you want to do right now. But day of the regents, let's write it all in. Write it all in. It's going to show up somewhere, part 3 or 4, I don't know, but it'll be there. All right, next up, let's look at the proof statement. Prove PT congruent to RU. You guys know this, right? That's not going to be true until we have to do what first? PT and SRU not congruent until? That's what I was thinking too. Triangles are congruent. This is a triangle proof. Prove triangles congruent. If you weren't here on Friday, I went over the 5 ways to prove triangles congruent. I'm not going to re-review that, so take a look at that. Can we first start with the right angles? All right, because my thinking is you put it on the diagram. Some of you may forget to put it where it counts. We do not grade your diagram. We do not grade the diagram. We grade what you put in statements, reasons. So let's start out by saying they are right angles. QTP and angle SUR are right angles. We will accept definition of perpendicular. I've done that all year. I write, you know how I go. Perpendicular lines form right angles. But if you write definition of perpendicular, it's fine. Next step, tell me they're congruent. Just more review that has nothing to do with this proof. If you know it's going to be HL, which it's not here, but if you know it's going to be an HL proof, you do not need to say the right angles are congruent. You won't be wrong either. Remember, any extra steps that are not needed are fine, but they have to be correct. Okay, if you add in extra steps that are not needed, but they have to be correct, you're not going to get any points taken off. Also, you're not going to get points taken off if you don't do this. This is just how I keep track of mine, angles and sides that I have. You know that, but it's not required. Let's keep going. I'm going to turn this over to you guys now. I need 2 more pairs of corresponding parts. I have a pair of angles. All givens are provided for a reason. Use it. Like PQRS is a parallelogram. Why is that needed? What other parts can you get now? Let's go in.
US and QT. They're not the opposite sides.
That's not the parallelogram though. QTSU is not a parallelogram. It's PQRS.
PQ.
The whole thing is.
Wait.
Right? Everyone, couple people made that mistake too today. Hey, this thing in here is just a quadrilateral. This whole thing is your parallelogram. So now what pair of opposite sides do you want? PQ and RS. There you go. Yep. Be careful there. Okay. Make sure we're using those sides. So PQ, RS. I know it's probably been a while. Ready for the reason? What were you given? What was this quadrilateral? It was a parallelogram. So we started off by parallelogram and then we draw the arrow, implies. Now tell me the property. Okay, what property did you just use there? Opposite sides congruent. There's a pair of sides. One more pair of something. Where's it going to come from? One more pair of something here. I got a pair of sides and a pair of angles. I need one more pair. Josh, what's good? It's a property, right? In a parallelogram, your opposite angles are congruent. There it is. There it is. This proof is not bad. I would be very, very thankful next Friday if our proof was at this level. Very thankful. P and R are congruent. Same reason as number 4, but instead of sides, we write angles. We talked on Friday, if you have 2 pairs of angles and a side, you're golden. You just got to know which method it's going to be. So anytime you have already proven two pairs of angles and one pair of sides, it's going to be congruent. It's just a matter of how. So next step, triangle QPT. I told you at the beginning we take off if you don't write your givens, and here's another place where we will take off if you do not write the triangle congruent statement in the correct order so the sides and angles match up. Okay, we do look for that. So QPT, make sure my angles and sides that correspond, which would be SUR, are written in that order. QP, nope, I'm wrong. Should be SRU, relax. All right, relax. Method. Where's the side? In between or no? Nope. Angle, side. And this is why we did all this work, right? To get to this part now, after the triangles were congruent, to say PT congruent to RU. Let it roll.
CPCTC.
That was not bad at all. I would be standing up in the aisles clapping if I were you next Friday if this is the type of proof we get. We know that's going to show up. We don't know where. And what else is going to show up? Let's go to the part 4 question. The big dog, 6-pointer. We know this is going to show up. Don't know where, though. Number 35. Coordinate geometry. The graph is on the next page, I believe. The use of it is optional, but somebody asked in my 3rd period class about scrap graph paper. You will get, next Friday, you will just get a booklet on your desk in Gym B. In the back of that booklet, reference sheet, scrap graph paper. Okay, so that's where it's going to be located, in the back. Also, your reference sheet is only one-sided. If you turn it over, it's blank. So you can also use the back of your reference sheet for any scrap that you want to do. All right. Everything's in pen except for the second time I'm going over this. This graph that you're doing right now can be done in pencil. But that's it. Any work we do on the outside now has got to be done in pen. Can I do the graph in pen too? Sure, that's fine. I am not allowed to give you a new exam though. If you do all this work and you have these big cross-outs and you have no more room, you got to find room. I cannot give you a new exam or a new problem. Okay, it's just you have the booklet you get is what you stay with. All right, let's prove it's isosceles. What formula am I going to need? Distance formula, yes. So as you guys know, keep this organized. I'm not correcting it. So whoever it is, make it nice and neat for them to look at. This is also why it's an advantage to graph. We could probably tell which two sides are going to be the congruent sides. So we can save our time. We don't need to do 3 distance formulas. We can just do it on side AB and side AC, because those are the ones that we're pretty confident in are going to be the congruent ones. You do not need to show me BC is not equal to it. All right, because even if it is, it's equilateral, and equilateral triangles are isosceles, so it doesn't matter anyway about BC. All right, I'll give you a minute or two. Find your distance of AB and AC. Or Pythag. I keep forgetting some of you guys use Pythag, which is fine. Hopefully we're getting 5 radical 2 out for both distances, 5 radical 2, or square root of 50, whatever one you're leaving. And we know what step 2 has to be. What did you just learn about those sides, right? They're going to either be congruent, parallel, or perpendicular. So what did you just learn about the sides? And we learned that they're congruent because distances are equal. And then step 3 is, all right, what do we got in our hand? What do we have on our hands here? Triangle ABC is isosceles. Because 2 sides are congruent. Doesn't have to, again, your wording doesn't have to match mine up here. Just get the point across. Get the point across. Just don't put 2 angles congruent. We didn't show that. All right, first part, all right? All right, second part, they threw a little translation in there on us. All right, big deal. Take triangle ABC, all right, move it right 5, down 5, and tell me what the coordinates are. Because it does say state the coordinates. So move your triangle right 5, down 5, and state the coordinates of A prime, B prime, C prime. What's up, Matt?
If we add an extra step in one of these proofs, then we just want.
As long as it's correct. It's got to be correct. If it's incorrect, we do have to take off. Even though it wouldn't matter anyway, we have to take off. But correct steps are fine. And we're all right with A prime, B prime, C prime now. This proof's not that bad. I remember this 2 years ago. Kids had problems with this next one. Because they threw in original coordinates with image coordinates and it messed with their mind for some reason. Proving the rhombus is easy. Oh, geez, if it's a rhombus for us, that'd be great. But it was just the coordinates of it, right? Because you got to go from A to A prime, A to C prime to C, and then back to A. All right, that was messing with a lot of kids. How are we going to show it's a rhombus? Probably the easiest way, show all 4 sides. Rhombus. All sides are congruent. Yeah, okay, that's distance again, but good news, you don't have to do 4 because we've already done 1. Which one have we already calculated? AC. So you do not need to do that work again. You can just simply rewrite it. AC equals 5 radical 2. We do not need to see the work. Also, I don't care what number the step is. I did 3 steps above. So if you want to call this step 4, that's fine. Or if you want to start over and call it step 1, just call it something so it's organized, right? And we know what order you're going in. So if you want to call it 4, call it 4. If you want to call it 1 because you're starting over again, that's fine too. Call it something so we know what the next step's got to be. So everyone right now is going ahead and finding the distance of the other 3 sides. A prime, C prime, and C prime. You know what it should come out to be. Same as AC. And if you want to go ahead and finish it, go ahead, because you guys know step 2, or the next step has to be, hey, all 4 sides are congruent, and then the final step is why is it a rhombus? So if you want to go ahead and finish it up, go right ahead. I'll do the same up here. I don't think I need to call on people or keep talking about it. You guys know the next step, show they're all congruent. And before I let you go on your own, somebody third period essay, it was really a great point, and I'll bring it up to you guys because you guys are at that high level as well. They said, hey, instead of showing the distance for A prime, C prime, could I just automatically say it's congruent to AC because translations are rigid motions and they preserve distance? Yeah, that's fine. All right, so if you wanted to get away without doing another distance, you could say those two are automatically equal because translations preserve distance. Pretty clever. All right. Any questions there? All right, let's work. Let's work. Call me over if you have any questions. Let's work. I'll put those questions back up. Everything should be familiar. Okay, should be, except for the construction.